We all know that it is possible to connect your own data to OpenAI models like ChatGPT and start chatting with your own data. On the other hand, we have Databricks, which is a unified data platform that can even support deploying our machine learning models through MlFlow. And here's the question for this video. Can we create a chatbot that uses OpenAI models like ChatGPT to chat with our own data and deploy this chatbot as an endpoint using MlFlow in Databricks? Then, let's go. Hello everyone, this is MG and welcome to another video. We previously recorded multiple videos about how you can use OpenAI models like ChatGPT or GPT 3.5 or GPT-4 to chat with your data, and you can connect these models to your enterprise data and start asking you questions about your internal data. And now here's the secondary question that I have for this video, which is how can I create my own chatbot similar to ChatGPT that can talk with my own data and deploy it as an application in Databricks. As we all know, Databricks supports MlFlow. That means you can easily deploy your machine learning models through MlFlow and create an endpoint for your machine learning models. Can we create an endpoint or deploy our large language model or chatbot application through MlFlow? This is exactly what we're going to check in this video. That means you can now deploy your large language based application or your OpenAI models that can talk with your own data, create that as an app, deploy it in MlFlow, and start interacting with it through an endpoint. Then, let's check it out.
Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. Alright, welcome back everyone. So in this video, we are going to actually enable a solution accelerator developed by Databricks to help us create and deploy a chatbot in Databricks using MlFlow to be able to chat with our own data. So this is the GitHub repository that contains all the codes that we need for this accelerator to create this chatbot in our own Databricks environment. And I will add the link of this repository to the Discord channel on the reference section. So I'm using that to sort of host all the references of the videos there. So later on, if you want to check any reference, any code of any videos I have recorded, you can just simply search in that Discord channel and find it out. So in order to actually use this GitHub or accelerator in your Databricks, you just simply need to come to your Databricks workspace, and under repository, you can click on add the repo, and then here you just need to simply copy and paste the GitHub repository that I just showed you. And again, I will add the link of that in the Discord channel. When you paste it here, just click on create repo, and that's it. This is what you will see. LLMAQA bot. This is all the codes coming in from this repository we just talked, and we are good to go with deploying these codes and create this chatbot in our environment. Well, it's very easy to deploy this. In one click, I can actually create this chatbot using MlFlow, but I want to go all the steps and codes that this accelerator used to make sure that we do understand how this accelerator works, and then leverage it for your own use cases. Okay, so in order to run this end-to-end accelerator, you'll see that there's something called Run Me. If you click on that, you'll see that it sort of provide you some description about how you need to run this, what are these steps are. But long story short, first it is installing some specific packages and importing them, and second, you need to specify what is your OpenAI key in order to, for example, leverage your GPT 3.5 model that you're paying for in your OpenAI account, right? So you need to have them here, and this is the place you need to paste your API key for OpenAI, because you want to use OpenAI models as your large language model to chat with your own data. You can change the secret name as well, but I just got it as is. I had mine, I removed it, it's credential, but this is the place you need to add yours. And then moving further, this is what is happening here. I am defining a workflow in Databricks. What is workflow? Consider workflow like a pipeline that has multiple steps. Then what are those steps? Each step is a Databricks notebook. What are those notebooks? Here it is. I'm saying that I want to run a workflow. For example, this is the first task, which is a notebook in the current working directory. I want to run it. So this is the first notebook as my first step for this workflow. Where is it? If I open my repo, there you go. The intro is here. So first we run intro and we'll check the codes. Then I have another code, which is assemble application. Then I have another code here, building document index. Then I have another notebook all the way going down, evaluation, and lastly deploying application. These are exactly these number 1 to 4 notebooks that I'm calling them as a workflow to run them over this specific cluster. Okay, that's it. And I'm just saying that run this as a workflow using this configuration. When I ran this gave me this link, and I realized that awesome, with just really one click. Of course, I ran all the README file, RUNME file that I just showed, the notebook, and when I executed the last cell, you can see that it created the workflow running all these notebooks that I showed you, these ones, as a step here. And then you just click on run now, you are done. What you will see when you go back to the workflow, you'll see that under job runs, you'll see that yours is running, and after 20 minutes almost, mine said succeeded. And I click on the job. Let's check it out. There you go. All these steps and notebooks that I showed you successfully executed in a sequence that was added in the job description. Now what I'm gonna do, I want to go over all these step by steps to see what is happening inside them, what are the notebooks and what they're doing, and lastly check out this chatbot together. Okay, what is the first one? Let me open this. You will see that this is just an explanatory notebook to just tell what we're gonna do. So long story short, what this accelerator is using, it is actually grabbing documentation of Databricks, documentation of Spark, and the forum of Databricks that has the questions and answers of people about Databricks and technical questions and stuff. So Databricks, for this example, gathered all those info to create a chatbot, and then you can go and chat and ask questions about Databricks documentation and Spark. So assume that that data can be your data, that can be your company data, a data that is not available on the internet, and ChatGPT cannot answer that because the data is not available. But now with this technique, you can start creating a chatbot that answers questions based on your data. So here, Databricks documentation is used as an example that can be replaced by your data. So with having that database in place and we create embeddings on the top of that, then we can start asking questions by the model, large language model, and the answer is there for us. So this is sort of the logic of what we're going to do. It is running the notebook config to grab my OpenAI key stuff that we talked about. Then that's it. It's not really doing anything specific. It is just all about introduction of what this accelerator does, which is just what I explained you. Then what is next? If I go back all the way to my run, the second step is this notebook. So what we're gonna do here, let's check out. Now, if I move down, it is installing some packages like OpenAI, LangChain. These are the stuff needed for tokenization, creating the prompts, connecting to large language model, creating a vector database with face, and doing some semantic search, and some other specific libraries that is needed for executing this accelerator. Then importing all those packages we just installed, coming down, here is the raw data that Databricks use for this accelerator, which can be your company data or any internal data, something that is not available on internet as an example. But here for this example, you can see that I have the text about Spark, Databricks. If I scroll right, you'll see that I not only have the text, also plus the source of the text. So where this text is coming from again the Spark, Apache Spark documentation with the relevant text beside it. Okay, now what this accelerator does, it will convert this to a table, a delta table. Now I have it with 7,000 rows, and you can see each row is a chunk of text. Now what we're gonna do, in order to answer questions about this data, we have to create index of this data, because We cannot bring all these data to ChatGPT as an example to tell that, hey, answer this question based on all Databricks documentation. No, we have token limit. So what we're gonna do, I in details explain that how you can chat with your data and create embeddings and stuff to a separate video. I will add the video to the top right of this screen, check that out. But long story short, we need to convert this text to embeddings. What are embeddings? They're just numbers that are understandable by these large language models. For example, I give that text, I generate a bunch of numbers out of this text, so when a large language model see that text, they can understand about the context. Now, when later on I ask question, what is a Spark? Based on embeddings of my question and the embedding of this text, it will understand that MG is asking about a Spark overview. So it will retrieve that chunk of text for me as the answer. That's why we need to index our data and then create word embeddings. How we create word embeddings or how we convert these texts to those numbers, again, we use OpenAI models. So moving down, we were actually here. I'm saying that this is the raw input that I have. We have the text, we have the source, and sometimes these texts can be pretty long. For example, this code actually is giving me the longest text in the data frame. If I scroll all the way down, look at that. It's just one row of that table. So it's a huge text. And of course, we cannot, even if I want to pass one of these chunk of text to the model, that can be long enough to give me the error of, hey, you passed the token limit. That's why I need to convert these texts into chunks with fixed size of chunks. And you might say that, MG, if I split my data to chunks, I might miss the context. That's why we do overlapping. So a repeated portion of chunks will show itself in more than one chunk to make sure we are hosting the context there and we are not missing any specific value or story there. But the challenge is, what is the best chunk size for me? And what is the best chunk overlap size? Quite honest, there is no direct answer for that. And as Databricks mentioned, it is like art than really a science. So for this example, I saw that Databricks used the chunk size of 3500 and the overlap of 400. But based on the type of your text, how much of overlapping is needed or not needed, and what is the limit token of your OpenAI model, if let's say you're using GPT-4, that's another scenario. If there are more GPT models coming in with a higher rate of token limit, these numbers will get changed. So I would say start with as is, but there's a place and I would say there's opportunity here to play with these numbers to make it further robust. Now we know that, okay, let's say this is the chunk size and the overlap size. Here's a user-defined function to convert those raw inputs to fixed chunks. So do not sing that long text which gonna cause us token limit. This is the UDF, user-defined function, that received the text and split it, and then based on this chunk size and overlap, it will give me the chunk data, which is this one. You can see this is one chunk, the text, and where it's coming from, here's the source. Now, these chunks are ready to be retrieved by a user question using ChatGPT as an example, right? For example, if I scroll up, I want to ask, what is the first text? Spark overview. I want to ask, hey model, give me a Spark overview. What is Apache Spark? Okay, so the model should go all the way back and retrieve this one. Based on word embeddings, it should understand that I'm asking about this chunk. But where do we need to host these text files and chunks? How the retrieval gonna happen? That's why we need to create a vector database, because we want to convert these texts to embeddings, which we need vectors to host numbers. So your vector database can be Redis, can be a new vector database that Azure Cognitive Search announced, or I think Azure Data Explorer actually support vector search and storing vectors. But here, for this example, Databricks is using Face, which is, I think, created by AI research team in Facebook. So it is using your disk to have your featured vector database as something internally located in your disk that Databricks is interacting with it. But quite honest, that can certainly be replaced with anything that you have in, let's say, enterprise. So it is converting all those chunk values to pandas data frame, and then it is splitting the chunk text and the metadata of those chunks. I am splitting the text and the source. Source is metadata. Why? Because I want to store them to a vector database. And there you go. It is actually talking about, I think, Face, which is a vector database used, developed, yes, by Facebook AI Research. And you can see here that it is used OpenAI to convert those text to numbers, which we call it embeddings. And it knows which model, which token and stuff, we add that in the configuration. Then, this is how you enable Face. You say that, hey, this is a vector database. Here are the embeddings, and here's my inputs we generated here. And here's the source of those inputs, metadata we generated from here. Now, I can save my vector store to a local path in Databricks DBFS file system or disk. Again, that can be out of even Databricks. That's it. Now we created a vector database. We converted the text in embeddings, and now the embeddings are indexed and chunks in my vector database, which I'm using Face. Now what is next? Let's go back to my run. I think we finished the second step, right? Yes, we are in the assemble application step. Let's see step number 3, what happened. Now we are here. We have a vector store, we have the text and the URL of that where that text is coming from, which we call it metadata. And now we are here to start asking the question, and we need to bring the relevant text from vector store to answer the user question by opening a model and then answer the question. Okay, let's do that. Again, some packages need to get installed, importing those, coming down. Let's say here is a question that I want to test. How to register a model in Databricks. Although this information is available on the internet, maybe you can use Bing search to answer this question. But again, this is an example. That can be your internal data. For example, you have a process of opening a support ticket in your company, which is called Company X. So the question can be, how can I open support ticket in Company X? That info is not available on the internet, but you can still get the answer back. So this is how you can retrieve the relevant documents from your vector store. So I'm saying that first I need to open the vector store that we created to access the embeddings, right? So I'm loading that here. And then I'm saying that for answering this question, that question might be available in more than one chunk of data. So maximum bring the most 5 relevant text sources that I have in the vector store to answer that question. That can be any number you can specify. And there you go. For example, I had just this question I asked, and it says that, what was the question? How to register a model in Databricks? There you go. It is talking about MlFlow and how to register a model in Databricks, right? Okay. Now, what we need to do, we need to assemble and create like a function or a wrapper function to have that end-to-end process. Give me a question and here's the answer. This is what we're gonna do. But of course, we need to create a prompt. For example, the prompt should be, hey ChatGPT, you are an assistant for MG, and MG gonna ask some questions about his company internal data. And in order to answer that question, you need to go back to this Face vector database, bring the relevant sources, and here are the sources. For example, top 5 sources. Take a look at them. Answer MG's question based on these 5 sources that I brought for you. You see, I'm sort of defining an identity for my GPT stance model, that what you're supposed to do and how you're supposed to answer that question. But do I need to prompt this all by myself? The good news is no. Because that's a very common pattern of creating a chatbot to chat with your data. The LangChain develops some prompt templates, and Databricks Accelerator is using those prompt templates to generate that template. So you can see there are 2 types of templates: system message template, human message. So what are the differences? Here it is. The system message prompt show instruction to the model about how we want to respond, and human message template provides the details about the user initiated request. So if I scroll down with having this loaded from LangChain, and of course telling the LangChain what model I'm going to use to answer, I'm just saying that bring large language model chain based on this prompt template. Now I know what are the prompt and what are the model that I'm calling to generate the answer. How? Here is what I'm going to do. So I'm saying that go ahead to all the docs that I grabbed from the source to answer MG question, get the answer from the source, and if the answer is not known, that means it was able to retrieve the answer, then print it. How to register a model in Databricks? Here's the answer. So now I want to deploy this model to create an endpoint. Not study model, deploy this application to create an endpoint. For example, I give you URL and I say that if you have any questions about MG's data, use this URL, send your request through HTTP call or wherever you are and get your answer back. That should remind you MlFlow, right? This is exactly how I deploy machine learning models in MlFlow. You train your model, test your model, validate it, log it in MlFlow, and deploy it in MlFlow. Then MlFlow will give you the integration of MlFlow and Databricks will give you an endpoint that you can call it and have the predictions back. This is exactly what we're gonna do, but don't forget, we are not deploying OpenAI model here. No. ChatGPT is not a model that I have trained, so I'm not going to deploy, and I cannot even deploy it in my Databricks. I'm deploying the code, the application that I have to interact with OpenAI and answer my internal data question. Then how can I deploy this? You need to define your application in a class or your chatbot. It is just simply saying that I give you the prompt and retriever process, which is the face vector data store, and the large language model that you need to talk. If you see any of these abbreviations in the text like DBR, it might don't know what does DBR mean, so I'm giving some heads up. These are the abbreviation. And I want to make sure the answer is valid or not. So if you see I don't know, not clear, sorry, no answer, that means ChatGPT was not able to answer. That's a bad answer then. Or if it's a good answer, then get the answer from it and make sure we are under the timeout limit and get the results. If we have that as a good answer, then provide me the answer with the highest rank in the source. I mean, based on the most relevant chunk of text, the number one that we got out of that 5, answer it, and if the answer is there, retrieve the back results for me. This is exactly what this wrapper code does. I just explained it very fast, but check that out, the details. You can modify, change it. Some of them are very relevant to this accelerator. I think you can remove them, change them, or even this part can be further modified, or even more simplified, or even get more complex to add more scenarios. Okay, now when I have this class, I can just simply call it and get my answer. The question was how to register a model in Databricks, and the answer is back just through calling this class, which I defined it on the top here. Now I feel I'm ready to persist that solution to MlFlow. Then the rest is simple. We can have a Python function way to register this application as an MlFlow endpoint, to actually deploy it later on as an endpoint. And I'm saying that this is the class I want to persist to MlFlow, and this is the class created for creating a wrapper for registering that under MlFlow. And then with having that wrapper in place, I can say start MlFlow, log whatever I created on top. What? It's a model, but not OpenAI model. That's my chatbot that I am logging actually and persisting to MlFlow here, with some package requirements needed, some configurations, and I'm done. If I go to, let me actually check. If I go to machine learning models, there you go, version 1 created. This is my chatbot wrapper that use OpenAI with all the logics I specified to actually interact and ask questions about my own data. If I click on source run, it will open the notebook that I just showed you. So if I go back, again, this is models. If I go to experiment, this is experiment related to this accelerator I created actually. So I click on this one. This is the latest one and only one I created. If I click on this, there you go. So you can see that pickle file is the class that we talked about, which is calling that OpenAI or large language model, and with all the class we specified to retrieve the most relevant source of data from vector database and then generate the answer. And you can see that these are the requirements we specified if installing OpenAI, LangChain, so on and so forth. So getting back to my workflow, and that's the job that we specified. Click on that. Okay, we finished this step, assembly, and now we want to evaluate this MlFlow wrapper that we actually configured. So click on this step. Now for the evaluation, here's what I'm gonna do. I want to see how the solution is accurate for answering someone's questions about the documentation that we indexed them. For example, if someone asks what is Databricks, making sure it is not going to answer Apache Spark is blah blah blah. No, it should answer first what is Databricks. So how we can do that? Well, you need to have a subset of labeled data. For example, here is a question that I ask, what is Databricks? And here's a sample answer. Databricks is a unified data platform that supports this and that and that. So you need to have that labeled data. Then you give it to the solution, and this solution will answer what is Databricks question, and then we compare how close the answer of this solution is to the labeled answer that we have. But then how we evaluate, we're gonna use LangChain. So let's check that out. So here I am importing that sort of MlFlow wrapper that I had actually logged in the previous step. And then here Databricks Accelerator is using a labeled data. For example, what's the difference between a Spark and this cache in Databricks? Spark cache and this cache. And here's the answer inside this labeled data. Now we're gonna give that question to this solution that we implemented to see if the answer is close to this one or two. But how do I assess the answer is close to this one or not? For doing so, if I scroll down, it is using LangChain evaluation called evalchain. What it does, it will actually use an OpenAI model by itself or a large language model to check how the answer of your solution is close to the answer of your labeled data. If it's pretty close, it says it is correct. If not, it says that it's not correct. So it implemented this logic, and check that out. Here's a question. Here's what our solution that we just created through this accelerator answered. And here is the answer from the labeled data. And how these two are similar? Well, the evaluation methodology by LangChain say that these two are sort of pretty close and true. I can see most of them are true. There you go. We have a false one. Actually, let me see why it's false. So what is the question? Oh, okay, because we had no prediction. Interesting. I want to see if we have more false examples. Okay, it seems they're mostly true. Okay, false, false. What about this one? Okay, what's the difference between DBFS and UC? Okay, let's see first what is the real answer. The correct answer, hopefully I didn't lost the row. I think I did. Let me scroll up. There you go, this one. So if I go here, here's the answer. DBFS is Databricks file store, of course we know. And Unity Catalog, that's actually UC. So Unity Catalog is a whole different approach for data governance and stuff. So these are totally different. But let's see what was the answer of our solution, which is false. If I go right, there you go. I don't see any information in the context of, okay. So it was not able to fetch the relevant data from here. So the answer is not even close to the actual answer. That's why the evaluation is false. So you see what's the approach and what's happening. And now we can just simply understand in general, what's the percentage of true scenarios? 91% of the time. Not bad, right? That's it. Now I'm going to deploy this solution through MlFlow and create an endpoint out of it. So going back to my whole workflow, we're in the last step, right? Here, deployment. This is exactly like how you deploy an endpoint for your machine learning model when you have it in MlFlow. That's it. You just grab that latest version of your register chatbot and we push it to production. You see that I am getting to the area of LLM ops or ML ops for large language model applications. Now you have MlFlow, you have stages, evaluation, dev, staging, prod. That's a whole different topic by itself, and if you're interested, let me know. We can have a dedicated video just about LLM ops, which is a new trend of how to apply and customize ML ops for large language models. But you will see that I'm giving you some heads up. This is what we're gonna deal with. And now for having that model deployed, you need to specify some configurations for that. Of course, you need to have the name of that model, what gonna be the version you want to have that in deployed, and you know that this wrapper needs my OpenAI key and circuits that can get from the config notebook. And remember, when we create an endpoint, we can navigate the traffic because we can have multiple instances running over one endpoint to navigate and dynamically allocate the traffic. Here, we just have one system we want to deploy, so 100% of the traffic goes to that endpoint. Then here are just helper functions, how we create an endpoint. If that endpoint exists, then just update that one. If it doesn't exist, then create it. We can just use it as a reference. And then that's it. It will start it for me. It was waiting to make sure its endpoint is done. Took 5 minutes. And the endpoint was ready. So it gave me the URL of my endpoint. If I click on it, which will give it for you as well. There you go. Now you have a real-time endpoint listening 24/7 for any questions to get it answered. If I click on that, use model for inferencing, there you go. Oh, sorry, if I go back to the registered model again, this is the model that I have, this is the endpoint, there you go. Now, for querying this endpoint, you can see that you can test the endpoint here, or that's how you curl, and or how in Python you can submit your question about your internal data and get the answer back. Here's actually an example that how it did it in this notebook. First, go all the way down. This is the last step of this workflow. You'll see that it's using the same helper function that, hey, this is the URL of my large language model application. Give me your question and get the results back. There you go. Here's my question. What is, for example, this blah blah blah, what is a request, and the answer is back. I have actually a notebook that I can test this even further. If I go to LLM, there you go, deploy application. Scroll all the way down. That's the same notebook that I just showed you, and check that out. I can even change my question to say, for example, how can I create a compute cluster in Databricks. Okay, so it will call that model endpoint that I created real time. Let's see what's going to be the results. And it is calling, of course, my endpoint that we just created. Still running. There you go. To create a compute cluster in Databricks, follow these steps. So to wrap up what we did through this workflow end to end, I'm going to show you again that we deployed this accelerator provided by Databricks. We went through all these steps. We had some notebook configurations to add our OpenAI key stuff. Then we started indexing our data. Here we documented Databricks and Apache Spark, we indexed that. Then we used a vector database to host our embeddings, and we used Faced for hosting those, and of course we used OpenAI to create embeddings. Then I had the user question get submitted and check what is the relevant source of data for my user question and bring it to the prompt. How we did it? Using the prompt template of LangChain and using Faced to calculate the similarity and bring the relevant data back for me. Then with having that relevant data submit to the OpenAI model, we were able to get the answer back, and we had to evaluate how good our approach is. And we used LangChain again to evaluate it, and lastly we deployed that as a wrapper through MlFlow to be able to have a real-time endpoint to call this, have the answer back. That means if I give you my URL endpoint to how to call it, and if you have permission to authenticate, then you can call my endpoint. If you have any Databricks question, push the question to the endpoint and get the results back real time. Now, have this endpoint integrated in your Teams bot, in your Slack channel, in your website, anywhere you can have that chatbot embedded, as long as you have that endpoint URL and add it to your application code. So think about it, how you can use this accelerator to start developing your own customized solution and your own internal data using Databricks, MlFlow end-to-end, and of course your own customizing vector database if needed. And I hope you enjoyed this video. Make sure you write down your comments in the below section. I want to make sure I'm reading them all, respecting what you would like to hear the most, so I will get the next content prepared for you. We'll see you in the next video.
Weak people revenge. Strong people forgive. Intelligent people ignore. Dream big, my friends, believe in yourself, and take action. Till next video, take care.